Look at the calculator in doing probability type problems, combinations and permutations, those type of things. Okay, so we'll start off here, the counting methods. And remember, we had the addition rule, the addition rule and the multiplication rule, so we have to decide. But again, this video is just primarily to focus on the use of the calculator. So I'm not necessarily going to go over concepts and how we might use it, but in this one here, how many different sequences can be formed using all of the letters of the given words? Well, order is important because it's a sequence. However, in some of these, if there's repeated letters, then we can't tell the difference about when one was used in the other. So we'll do this both at a time. So this first one. There are 1, 2, 3, 4, 5, 6 letters, and they're all different. None are the same. So this is going to be a permutation of 6 items using all 6. We can also see this is going to be 6 factorial. But let's go ahead and calculate that. How would we calculate that? You get 6 times 5 times 4 times 3 times 1, but thinking of it as a permutation of 6 items using all 6, we go to, we don't do the second button. Well, quit. We use the math key. We go over to probability and down to permutation. Let me do it this way so it'll work with everybody. We're going to do 6 math probability, not combination, permutation. We'll hit enter, and notice the 6 goes right in there. Some of you have to do the 6 first, but that goes there, and then we're going to use 6 of them at a time. It's 720. That's the correct answer. So that's how we could do a permutation. If we only used 5 of them, then so forth and so on. But that's how to use the technology. Now with the elephant word, it's a little different. We're going to use both a permutation and a combination. So what's best to do, and again, the way they did this in WebAssign was a little different because they actually put out the problem. But what we're going to do is how many letters are repeated? Well, I see 2 E's. So that's one, and that's the only repeated letter I have. There's a total of 1, 2, 3, 4, 5, 6, 7, 8. 3, 4, 5, 6, 7, 8. So this is the hardest part. So there's 8 letters total, 2 repeated. So the way we do this is, well, first, okay, let's deal with the 2. See, if you put this E first or that E second, it's going to look the same. It's not going to make a difference. So that's really, order's not important when they're the same letter. So out of the 8 letters, I'm going to do a combination with 2 of them. That will be the E's. So that 2 takes care of, now we're down to 6 letters where we're going to be doing a permutation. So there's 6 letters, and we're going to use the rest of that 6. So you'll see that we've already sort of done this. This is going to be 720 times whatever 8 choose 2 is. But I can do this all in the same step with my calculator. So I'm going to do 8 choose 2. So I put in the 8 math, go to probability down to combination, enter. I'm going to choose 2 this way, where order's really not important. You can't tell the difference because they're the same thing, times 6 math probability and permutation. We're going to choose the remaining 6 with a permutation. That gives us 20,160, which is the answer at the end. So finally, we can do the same thing with the technology. We go to this one, and again, first we count how many letters there are. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. how many repeats are there? Well, there's one. Let's count the E's. I can see there's more than one E's. There's 1, 2, 3, 4 E's. What else is repeated? X, there's only one. C, there's 1, 2 C's. And then there's 2 L's. I can see they're right together. And then there's 1 N and there's 1 X. And that's 4, 6, 7, 8, 9, 10. Okay. So we do the same thing. We're going to do the combination parts first, so it doesn't really matter how we do the E's. That's going to be a 4 choose. Oops, sorry. You have to have the bigger number first. Here we go. It's going to be out of the 10 letters. We'll choose 4 where order's not important. So that brings us down to 6 letters left. So for those 6, we'll choose 2 of them. That's the C's. Then we'll choose the 2 L's. So that's 6 minus 2 is 4. 4, choose 2. And now there's 2 letters left. And that's going to be a permutation of 2 choose, or 2 permutate 2. So this is the multiplication we're going to do. And we just go ahead and we enter the 10, math, probability, and that's a combination of 4, arrow up, times 6, math. It's just kind of tedious to do this, but we can do it. Choose 2 times, and I think you have to have these times. Maybe this is where it is. I was thinking it was matrices, but anyway, I think you have to put those times between them. 6, choose 2, and then we're going to do a 4, math, probability, choose 2 times, so we got that one, that one, that one. Now we need a permutation, so we do 2 math permutation of 2. Hit enter. 37,800. And well, let me just delete this. I'll just go down to the end. That was what question was that? That was question 18. And when we check out question 18, 270, 20,160, 37,800. And you don't have to use the formulas. They're built into the calculator using this process, but you do have to know when something is, when the order is important and when it's not. So when we have 4 E's, the order is not important. We can't tell the difference between them, right? It has no meaning. So that's the way to do those. What was I thinking of next? Let's see, because that's pretty much all we're doing with all of these. Is you can use those whenever, again, we use permutation whenever order is important, combination when it's not, and we can do it in just that way. Now, let's see, with probability, let's do this in a little different way. We do some counting. I think we're going to see these are really just kind of adding and subtracting, and you kind of going through there, but there are a few of these. Yeah, so these will be in the lesson, but for I'll kind of do this. It's just really a division problem, so I'll show the technique that we can use using the calculator, basically to get the answers in the right form. So let's take this one. We got the bag of marbles. This is actually I'm making the video before class, but we'll take a look at something like this in class. So we've got a bag that contains 5 red, 6 green, 4 blue marbles. The first thing is how many are that? That's 15 marbles total that we're choosing from. 4 are drawn at random, so there's only going to be 4, so we're going to pull them out. Now the order that they're pulled out is not important because it's random, and actually they're all taken together, so order's not important. Again, that concept that we talked about, putting the books into a box, whatever you take out of the box, the order's not important. Okay, if we were to put them on a shelf, then arrangement's important. Okay, so what is the probabilities of following events? Okay, probability is good things divided by bad things, or no, sorry, no, it's good things divided by total things. So what we have to calculate, how many are all green? So that would be how, if we got 4 greens, right? Well, the way to do that, how can we choose 4 greens? Well, there's only 6 that are green, so what we have to do is that 6 choose 4. Again, order's not important. That's how we get 4 greens out of that bag. We only choose from the green ones. But the total things that could have happened are that there are 15 in there, and we're going to choose 4 of them. So it's just this kind of a division problem. And what we'll do is we'll use, there's a couple ways we can do this. I'll show you the way. If your calculator has this, the 84s, and again, sometimes the older ones don't, alpha F1, so it's a green, see the F1, so this key becomes the F1 key. I get to choose this little fraction thing, numerator over denominator, and that's when I do that, I hit enter. Notice I get a little template. It's just a nicer way to do it. And I'm going to do 6, choose 4 on the top. So I do 6, math, arrow over to probability, go down to combination, and we're going to choose 4 of those for the green. And then for the total, I'm going to do out of 15, I then choose, we're going to choose 4. And when I calculate this, before I calculate this, I could, let me do it sort of the wrong way. Oh, it gave me a fraction. That's the nice thing about using this template. It automatically will give you a fraction. I forgot about that. Now, the other way, if you don't have that feature, so if you do, go ahead and do that. If not, what we'll do is we'll use the division. So we would do sort of the same entry, 6, math, probability, choosing 4, arrow up so that you're not down in this level, so that you're at the sort of the main level. We're going to divide by 15, choose 4. And again, we'll see some of these we're going to have multiple, so we'd have to put a parentheses, but I guess we'll take a look at that one when we get there. 15, math. Be nice if they had like a storage key where you could say, hey, I'm going to use this a lot, so let me put it on a key, but I don't know, maybe they do. So this is it. I think in this mode though, let's just test it. I don't think it gives us a fraction. Yeah, it gives us a decimal, and we were supposed to get a fraction. So I'm going to arrow up, hit enter. On this calculator, it brings it back. You could also, there's an entry mode. Let me just do that. So if I go second entry, it brings back the last entry. And then if my calculator worked this way, I go to math and I choose fraction because I wanted to leave it as a fraction. Okay. Multiple choice test, you'll be able to choose. If they didn't care either way, that's 0.01. That's about a 1% probability of getting all 4 marbles to be green, or 1 out of 91. Okay, so that's that one. All are the same color. And again, we'll go through the different ways to do these. Let me, I'm going to have to think about that one. I haven't, because basically I think you have to do 3 different ones. They're either all red, all green, or all blue. Oh, blue marbles, yeah. And then you would add those together. Well, let's just go ahead and do that while we're here. I just got to throw a twist to me because I looked at everything else, and we'll do them not all green because that'll be an interesting one. So all are the same color. All would be red. So we just did the all green one, so we know that that is 1 out of 91. So we won't do that necessarily again, but all the reds. So that's going to be, out of the 5 reds, we choose 4. And we can do it this way because they're all going to get divided by a common denominator of 15 over 4. You could do them as separate fractions too, but this will be a lot easier to enter. Plus, what's the probability of getting all 6 green? Well, we already know, but let's go ahead and do this one. 6, choose 4. And then, because it just makes it easier to do it. And then getting all 4 blue marbles, well, that's 4, choose 4. So these are added together because you're going to do one or the other. You either get all reds, you get all greens, or you get all blues, right? So we could put this in. Now if we had marbles like there was 3 yellow marbles, we'd leave that out because there's no way to get all yellow, right? If you're choosing 4, you're not going to get all yellow. So the only way, you know, again, we don't have one of those, but we toss that one out. There's only a way to get all red, all green, or all blue. Okay, we add these together and then we divide. And so the way we do that here, again, we can use our fraction key, which if you've got it at alpha F1, it's a beautiful tool to have. It has a nice thing. We can put it all in there. But I'll do it because I know some of the older versions don't have that that template. So we can still do it sort of on the line. We just, in the numerator, we're going to have to want all of this in parentheses so it's all taken together. And then we're going to do 5, math, probability, combination. And then we're going to take 4 of those. We're going to arrow up, get on the line, plus math. And if you've got a friend that has a version that works, you know, better, maybe see if you can borrow it. Did I put the number in? I can't remember. Let's see. Oh, I didn't. So at least with this version, I can come back. Some versions you have to have the number 6 first, because you know otherwise the order's not right. Anyway, figure out how yours works, and then this one I can put it in first, and then it knows that that's going to go into the choose part. 4, choose 4. And then we're going to divide this all by the total things that can happen. Well, we've got 15 marbles, and we're going to choose 4 of them. Order's not important. So that's good things over the total things. And so since I'm kind of doing this, okay, we get that. But remember, second entry, bring it back. Let's go to math, fraction. And now let's do it. It's 1 out of 65. And let me clear my writings. This was what? This was 27. 1 out of 65. So yeah, I'm doing a little bit. So I'm going to post this today. If you look at it before tomorrow's class, Wednesday's class, this kind of thing we're basically doing in class. That's all there is how to choose marbles out of a bag. There's these different ways. Let me talk about not all green. Now, you could think about, well, if they're not all green, that means they're red and they're maybe have some green, or they're blue and have some green, or they're red and blue, or none of them are green. That would include this one. It's just saying not all are green. So when you have a statement that says not, the best way to calculate that is 1 minus the R. I don't know if the complement, right? So what's the complement of not all green? Not all are green. The complement is, yeah, all are green. Now, we could do this a little, since we've calculated the all green, we know that's 1 out of 91. Well, we're going to subtract from 1, and the cool thing about 1 is it's so easy to write as a common denominator. If 91's our common denominator, that means 91 is in the numerator. So what we end up with is 90 out of 91, and I'm going to show you that that's what we end up with. So not all green, the way we go about calculating, and if we didn't have all that, we say, okay, let's calculate how many are green, and we'll subtract that from 1. So we're going to do 1 minus. How do we get all green? Well, we talked about that. There's 6 green. We're choosing 4 of them. So that's going to be a 6 math, probability, and we're going to, from those 6, we're going to choose 4. But remember, this is a probability of this happening, so we're going to divide by 15. Math, choose 4. And then let's see if this works. I haven't got the parentheses around it, but what if I just make this last one the fraction? I'm just testing it out. It might work, it might not. Because it's going to make this last one into a fraction. I think it will keep those one subtraction as a fraction. If not, put a parentheses around it. It did, 90 out of 91. And you'll see for 27e, come down here, 27e, 90 out of 91. So that's the easier way to do it. And again, just using your calculator. And again, I just want there's some things you have to be careful about, that you're not like getting the division down with the 4. Then it's weird things happen. I'm not exactly sure what, but well, let's play with this a little bit. I mean, you can go if you want, but what if let me see, let me delete this and let me go down here. What if I would have put the division here, and then I go to these next things? I think this is going to be 4 divided by 15. I think I'm going to get some kind of error probably. Yeah, it just doesn't know, and I go, oh, my calculator's not working. What? Well, no, my calculator's working fine. It's, as my friend used to say, it's the nut that holds the wheel. Driving a car, the nut that holds the wheel is loose. In this case, I guess I'm the nut driving the calculator. So that didn't work. So just be careful about these little things. The syntax of the calculator, that's what these are for. Practice beforehand. Don't think you can borrow your friend's calculator and just going to know how to use it during the exam. Use it to while you're doing your homework, while you're everything, and if you need to borrow one, but make sure you know how to use it, and the only way that's going to be is through use. Pretty much that's it for our probability and our counting. Different ways to use it. We really have just those two that we need to worry about. All right, we'll leave it there, and then I will do individual solutions for each of these. Maybe we'll see how things are, but we'll make it all work. Thanks.